Let's go ahead and work through an example here of actually calculating the curvature. Let's find the curvature given my vector function is t squared over 2t squared. Now, just as a quick reminder, curvature we define as being the magnitude of the first derivative of the unit tangent vector divided by the magnitude of the first derivative of our vector function. Okay, so I need to find some of these components. So first of all, let's go find the unit tangent vector. And remember, these are vectors, just as a quick reminder there. Let's see, this is going to be, the tangent is going to be r prime of t divided by the magnitude of r prime of t. And again, even though I'm not going to keep writing these all the time, as a reminder, those are in fact vectors. So r prime of t, this is going to be equal to the vector 1 t 2t divided by the magnitude of this, which would be the square root of magnitude of this, 1, because 1 squared, plus t squared plus 4t squared. So this gives me, see, 1 over the square root of 1 plus 5t squared times the vector 1t 2t. So now I have the unit tangent vector, but I need the first derivative of it. So let's see, I'm going to write this out in some detail here. T prime of t, I'm going to think of it in terms of d dt of 1 plus 5t squared to the negative 1/2 times 1t 2t plus, see, 1 plus 5t squared to negative 1/2 times d dt of the vector 1t 2t. It's just the product rule. So now that I've got it set up like this, let's go ahead and take the derivative. See, this would be negative 1/2 times 1 plus 5t squared to the negative 3/2 times 10t multiplied by this vector, 1t 2t, plus, I'm going to go ahead and, I'll leave it there. I was going to bring it down. I think I might in the next step. See, 5t squared to negative 1/2 times the derivative of this vector, which will give me 0, 1, 2. Now see, my 2's go cancel, my 10 and give me a 5. So what do I have here? I'm going to have a negative 5t over 1 plus 5t squared to the 3/2 times this vector 1t 2t plus 1 over 1 plus 5t squared to the 1/2 times this vector 0, 1, 2. So I need the magnitude of this, and finding the magnitude like this is not going to be pleasant. I need to add these together. Matter of fact, I'm not sure how I would find the magnitude without adding them together. That'd be very awkward. So let's go ahead and distribute this, and I'm going to factor this out, which when I do, this will come out, but it's going to leave me with a 1 plus 5t squared to the first power in the numerator. That's the only way I can factor out a 3/2 from a 1/2. So when I do that, I'm going to say this is equal to 1 over 1 plus 5t squared to the 3/2 times, when I distribute this, I'll get the vector, see, negative 5t, negative 5t squared, and negative 10t squared, plus, I need to distribute this, plus the vector, let's see what I have here, 1 plus 5t, oops, that's multiplying by 0, that was silly, this is just 0. Now multiply by 1, I'll have 1 plus 5t squared, and then I'll have 2 plus 10t squared. So now I can go ahead and add this. See, this is going to be nice and compact when I'm all done here. This is going to be 1 over 1 plus 5t squared to the 3/2 times the vector negative 5t 1 2. Okay, that's sweet. So now in this form I can very quickly and easily find the magnitude. The magnitude of t prime of t is going to be equal to the, I'm going to write all this out in detail. I hope I'm not insulting your intelligence here. I figured it sometimes it's easier to see all the gory detail to make sure you don't get lost in where some of these components come from. See, what's this going to give me? This is going to give me the square root of 25t squared plus 5 over 1 plus 5t squared to the 3/2. And I'm going to yank out a root 5. Because if I factor out a 5, the numerator and denominator will be the same, just different exponents. So that's going to simplify even further. That's going to be kind of cool. So I take the square root of 5 times, I'm left with 5t squared plus 1 to the 1/2 over 1 plus 5t squared to the 3/2. See, these are the same. So this is actually going to be the square root of 5 divided by 1 plus 5t squared. There we go. So that's not the curvature, that's the magnitude of the first derivative of the unit tangent vector. Okay, so as a reminder again, the curvature is going to be this guy divided by the magnitude of the first derivative of my original vector function, which I think we have up here already somewhere, don't we? Yeah, that's right there. See? Did the work and it's right there. So my curvature is going to be the square root of 5 over 1 plus 5t squared over 1 plus 5t squared to the 1/2, which gives me, what, root 5 over 1 plus 5t squared to the 3/2. So given any value of t, this is kappa. This is a curvature.